Factoring by GCF. Whenever you factor a polynomial, you're basically reversing the multiplication process. It's like the inverse of the distributive property. There are two steps. The first step is to find the greatest common factor of every term of the polynomial. The second step is to factor that GCF out, which means you're going to divide every term in the polynomial by the GCF. A few things to keep in mind. If the first term of your polynomial is negative, your GCF must be negative. The number of terms inside the parentheses after you factor must be the same number of terms in the given polynomial. So let's work an example together. 5x minus 35. So our first step is to find the GCF. So it might be obvious here what the GCF is, but if you're ever unsure, just go through and write all your factors of both terms, and then you're looking for the largest number they have in common. And then we have to check our x's. Well, we only have one x here, and we have a constant here, so our GCF is just the number 5. Okay, now we divide every term by our GCF. 5 divided by 5 is 1, so we're left with x. Negative 35 divided by 5 is negative 7, so we're left with minus 7. To check this, we could use our distributive property and distribute 5 times x is 5x, 5 times negative 7 is in fact negative 35. So here's our answer after we have factored the GCF out of our polynomial. All right, let's factor the GCF out of this polynomial. So let's start by just looking at our coefficients. The only sign we take into consideration is that first sign, and since that first sign is negative, we know our GCF has to be negative. Okay, so we can go through our factor pairs or list our factors for every term. And for this one, we find that the GCF of our coefficients is just 6. Okay, but we're not done because all of our terms have the variable x. They all have at least 2 x's, meaning we'll have x squared with our GCF. Another way to approach that is to think x to the 4th is x times x times x times x, x cubed, x times x times x, and x squared is x times x. And they all have 2 x's, meaning we'll have x with an exponent of 2. All right, now that we have found our GCF, we want to factor it out, which means we're going to divide every single term by our GCF. Here, it's important to remember that whenever we divide terms, we divide our coefficients and subtract our exponents. Okay, so here, negative 6 divided by negative 6 is 1. 4 minus 2 is 2, so we're left with a 1x squared. Negative 18 divided by negative 6 is a positive 3. 3 minus 2 is 1, so we're left with x to the first power, or just x. And then lastly, negative 12 divided by negative 6 is 2. And then 2 minus 2 is 0. And anything raised to the power of 0 equals 1. And 2 times 1 is just 2, meaning we won't have any x's here. So again, if you get an exponent of 0, we're not going to have that variable in our term. Now to write our answer, we always have our GCF first, and then we bring our terms, focusing on those signs, to be in parentheses. To check this, we could distribute negative 6x squared to all three of our terms, and we should get our polynomial. All right, let's factor this polynomial. So we're trying to find the GCF of 12 and 32. So we can go through all of our factors if we need to. And here we find that our GCF is 4. And then we look at our variables. They have in common 2. And then our variable y they have in common 3. So that means our GCF is 4x squared y cubed. You could have also noticed that they both have x's, so we'll take our smallest number of x's. They both have y's, so we take our smallest number of y's. All right, now we are going to factor out that GCF. So we're going to divide both terms by our GCF. To divide terms, we divide our coefficients and subtract our exponents. So here we have 3x, and here we have 8y squared. Notice y cubed divided by y cubed simplified to 1, meaning we don't have any y's. X squared divided by x squared simplified to 1, meaning we don't have any x's. And then to write our answer, we have our GCF, and then our terms following. Okay, I want you to pause the video and try this problem. Factor out the GCF of these 3 terms. Your first step is to find the GCF and then divide it out. Okay, so our GCF here is 3, because 3 divides evenly into 9, 15, and 12, and it's the largest number that does that. And then we notice all 3 terms have x's. Our smallest number of x's is x squared. And then all 3 of our terms have y's, and our smallest number is y squared. Remember, if even one term didn't have any y's, our GCF would not have any y's either. All right, now we divide it out. We factor it out. 9 divided by 3 is 3. 6 minus 2 is 4. 2 minus 2 is 0. 15 divided by 3 is 5. 4 minus 2 is 2. 5 minus 2 is 3. 12 divided by 3 is 4. 2 minus 2 is 0. And then 8 minus 2 is 6. And then remember, to check this, we could just distribute our GCF back out to simplify and get our original polynomial. Pause the video and try this problem. Here, to factor, we want to find our GCF. The largest number that divides evenly into 12, 24, and 16 is 4. Because our first term is negative, our GCF must be negative. All 3 terms have x's. The smallest number of x's they have is x cubed. And now we divide every term by negative 4x cubed. Negative 12 divided by negative 4 is 3. 5 minus 3 is 2. 24 divided by negative 4, negative 6. 4 minus 3 is 1. Negative 16 divided by negative 4 is a positive 4. 3 minus 3 is 0. And here's our answer, factoring out our GCF. To check this, we could use our distributive property to simplify back to our original polynomial. Pause the video and try this problem. All right, so our GCF here, 3 is the largest number that divides evenly into all three of our terms. All three of our terms have x's, and at most x squared they all have. And now we divide our GCF out. We factor it out. And we're left with 3x to the 4th plus 5x squared minus 4. And that's how you can factor polynomials with the GCF.